today we're going to look at an angle addition postulate problem. Okay, so we're going to start this. So as we're reading this, if H is in the interior of angle EFG, I'm going to stop right there, and we're actually going to draw this. So H being in the interior of EFG, we're going to draw an angle. Angle EFG. And when it says H is in the interior, I could actually put it anywhere here. But I'm always going to be careful with this to not put it right in the center, because we're going to talk about angle bisectors here in a moment. But I always start with an obtuse angle just to give myself some space to work here. As we continue to read the problem, the next thing we get is the measure of angle EFH is 75 degrees. So we're going to label that. So we're going to go down to angle EFH, which is right here. So this is 75 degrees. And then angle HFG is 10x degrees, which is right here. And then we're also told that angle EFG is 20x minus 5 degrees. Well, angle EFG is the whole figure, okay? And so one way to label it is to kind of show that it's going to be the whole thing, 20x minus 5 degrees. So the way we set up a problem like this is we're actually looking at this angle plus this angle to equal the whole thing. And so we set up an equation, or this is something we can use, 75 plus 10x equals 20x minus 5. From here we just solve this equation, so we could add 5 first, which will give us 80 plus 10x equals 20x. Then we can subtract 10x on each side. We get 80 equal to 10x, and we divide by 10, and x is 8. Now, a lot of times when we're doing a problem like this, we may believe that we're done at this point. We do know what x is, and that is one of the things that it asks for, but it also asks us for the measure of angle HFG. So when I get that, I have to then plug my x value in. I'm looking for HFG, which is this one right here. So all I had to do to find the measure of angle HFG is to plug in 8 for x. So it's just going to be 10 times 8, which is 80 degrees. So we're also going to look at an angle bisector problem. Now, an angle bisector is exactly like it sounds. We have an angle, and to bisect it is to cut it in half. So we're going to start here with angle AFM. So when it says that ray, so this is saying ray FL bisects, so this time I'm actually going to try to put it in the middle. And the other thing I'm going to do is to mark that my angles are congruent. So I'm going to mark these two angles because those two angles have the same measure. They are congruent to each other. So once I get that, I'm going to go ahead and label what I'm given. So the measure of angle LFM is 11x plus 4. 11x plus 4, which is here. And the measure of angle AFL is 12x minus 2. And if I get a problem that's set up like this, since these angles are congruent, I can just set them equal to each other. So 12x minus 2 equals 11x plus 4. And from here we can go ahead and solve our equation. So we can subtract 11x from each side. We get x minus 2 equals 4, and x equals 6. So once again, that is one of the things that they asked for, but it's not the only thing. They've also asked for angle LFM. So if I go back to angle LFM, we're talking about this guy right here. It says that it's 11x plus 4, so I have to plug my 6 here in for this x. So it's simply going to be 11 times 6 plus 4, which is 66, plus 4, which is 70 degrees. So angle LFM is 70 degrees. The other one that they're asking for is angle AFM, which in this case is the whole thing. That's the whole thing here. And probably the easiest way is, since this is an angle bisector, and since this angle is 70 degrees, this angle must also be 70 degrees. So it's just going to be 70 plus 70, or 70 times 2. So it's 140 degrees.